Hey everybody, this is Alex Merced from alexmercedcoder.com. And basically this video we're going to do is talk about the different programming languages that exist. And we're not going to rank them. This is not about whether one language is better than another because it doesn't matter. The main thing is you learn programming fundamentals. You learn what functions are. You learn the concepts of functional programming and object-oriented programming. And basically, once you kind of have those fundamentals in any language, it becomes a lot easier to transfer to another language. Um, so generally, I'm going to put all these languages into four categories: interpreted, compiled. So interpreted means it's like Python, JavaScript, Ruby, where you don't compile it to like binaries. Instead, it gets interpreted by an interpreter at runtime. Compiled, you do compile it to binaries. So there's a compile step and then you run the code. That after it's been compiled. Transpiled means you're turning it into another language. So technically, this language isn't the final stop. You take this language, you transpile it to something else, and then you get interpreted or compiled. And then there are certain languages that are meant to run in a particular virtual machine, like the Java virtual machine. So we'll go through those. Okay. So first up, of course, is going to be JavaScript. Okay, JavaScript. Honestly, probably the language I would recommend be everybody's first language because it's a language that's just so ubiquitous in everything. So, like, why not learn JavaScript first? So, let's put JavaScript in there. Okay, let's make it a little bit smaller. But, I mean, JavaScript is the main language. It's a general purpose language. You can use it for pretty much anything nowadays. So you can use it to make mobile applications with React Native and NativeScript. You can use it to make desktop applications with Electron. You can use it to make backends with Node web applications. But the one place that is sort of only JavaScript's domain is front end browser based code. Really, up until recently with WebAssembly, JavaScript was the only game in town as far as introducing programmatic elements to your front end of your website. So, which is what makes JavaScript sort of one of the most dominant languages there are. So, a solid language to learn, a great language for learning a lot of these principles. It definitely helped me because you get basically JavaScript, since you can build like a website, you get like results right away. So it's a great way to just kind of really start seeing your programming fundamentals at work right away. And if you hear a bird in the background, I do have a cocktail, just to give you a heads up. Now, since I mentioned JavaScript, I figured next would be TypeScript. TypeScript is really just a superset of JavaScript, so it's its own language, but really it's JavaScript plus stuff. And it's not interpreted. Okay, there's no TypeScript runtime. Okay, because the benefit of TypeScript is that it's transpiled. So it has a compilation step where you're compiling it to JavaScript. And that's where you can catch sort of typing errors, because this is what TypeScript is. It's basically JavaScript plus typing. So you can actually type your functions, type your return values, type your variables. So that way, if anything doesn't match or doesn't match your typings, you can catch that during the transpilation or compilation step. So TypeScript is a language that transpiles into JavaScript. Okay. Next, let's talk about Ruby and Python. Also in the same boat as JavaScript, where they're interpreted languages. Okay. Now, both of them can be used for, again, anything. You can build mobile applications with Ruby and Python. Actually, let me get the right logo. That's just a picture of a little Ruby Lang. There we go. But Ruby, most famously, like far as like the job market goes, in the job market, it's most famously used for Rails, the web framework. But there's like Ruby Motion for creating mobile applications. There is all sorts of other Ruby frameworks other than Rails, such as Hanami and Sinatra and whatnot. So you can do a lot with Ruby. It's another language that's really easy to learn, has a really nice simple syntax that's a lot like reading English, making it a great. If JavaScript isn't your first language, Ruby is a good alternative. Same thing with Python. Python's also a very readable, easy to learn language. Python. Oh, Erlang. Okay. Let's get the Python logo up in here. Okay, now Python is probably one of the biggest languages in the world nowadays. And what makes Python particularly interesting, Python got there organically. Like, there's no like the thing you do in Python. People use Python in the blockchain space. They use it in web. They use it in mobile with the Kivy framework. They use it in data science. They use it in machine learning and AI. So you can literally use Python for anything. Okay, so Python again also has a really nice readable syntax. So if you Ruby and Python are probably, I would say, probably have the simplest syntax to learn, and Python just has a reach in a lot of areas. So while Ruby, an easy language that can do anything, it's mainly, it exists in the web space. It's not as used elsewhere. While a language like Python, it really does have like a heavy amount of usage in many other sectors. Doesn't mean you can't use Ruby for those things. It's just like if you're in the job market, you're probably going to find web work, back-end web work with Ruby, particularly in Rails. Now, here's the beauty of the thing about all these languages. If you're doing your own project, your own startup, it really doesn't, then you don't care. You use the language that you prefer. You use the technology that you prefer. Just keep in mind, you want that technology to be maintained. So if your project starts earning money, it's probably a good idea to make donations to the maintainers of the particular technologies you use, so that way they stay maintained. Okay, so keep that in mind. Last thing you want is to depend on technology. You don't support it, so in that case, one day they stop maintaining it and you have to rebuild your project. Okay, continuing on, then there's PHP. Now, PHP started as purely sort of like a back-end web language, but now there's like PHP runtimes and CLIs, and you can use PHP as a scripting language, and it's become a much more robust language than it once was, with all the bells and whistles of all the modern languages and syntactical features. Now has like arrow functions if you're using like PHP 7, which is really cool. Okay, I like PHP. Over half the web is done in PHP. Okay, WordPress is PHP, which is like just WordPress alone is like half the websites on the web. So there's a lot of PHP out there, a lot of demand for people doing like custom designs, which requires you to understand the PHP within WordPress templates, doing custom plugins, which requires you to create plugins using PHP. So it's a good language to learn. And PHP is interpreted by a PHP server. Yeah, it's not compiled. Now, as far as compiled languages go, of course, there is like the obvious ones, which are like C, C++. See if I can get an image with both of them. This works for me. Okay, so originally it was C. Like, C is like one of the oldest languages around. And what happened is eventually someone wanted to add object. C doesn't actually have classes. Like C, what you have to do is you have structs. And you would take those structs, which are just basically, they're like classes without methods. And then you'd create methods that relate to those structs. So you don't really have object-oriented programming the way we know it today, like classes. C++, literally the reason why it's plus plus is because and actually its original name is C with classes. C++ was just sort of the object-oriented version of C. Okay, they're both still heavily used languages because they're so low level, meaning when you say low level, it just means one, you have to type a lot more code, but because of that, your code is not assuming a bunch of stuff. Because when you're using JavaScript, Ruby, Python, PHP, they're doing things like garbage collection. They're higher level languages, which means there's a lot of things that are assumed underneath as far as memory management and other things, so that way you don't have to worry about them. But that creates overhead as far as the speed of your application at large scales. Again, I also live in Brooklyn, which has a lot of sirens in the background and fun sounds in the back. But with C and C++, okay, what happens is you don't have those things. Those things are going to be managed by you, but the overall program that gets compiled is faster. Also, just compiled languages are faster in general because you're not also translating the code at runtime. You compile the code, and then when the code's running, it's just running. There's none of this translation going on at the same time or interpretation. So you have that too. So generally when you need speed, C++. Interesting story. Facebook originally created Facebook with PHP. And to get that speed, what they did is they actually created the hip hop virtual machine, where they created a virtual machine that takes PHP code and translates it to C++. So that way you could continue the code in PHP, but get the additional speed of using C++. Very interesting story. Facebook has a lot of interesting aspects to its development. But C++ has been around for a while. There's a lot of cool sort of newer syntactical things in newer languages that people like. Okay, so people have created newer, lower level languages to kind of do the things that you would do with C++, particularly Rust and Go. Okay, so let's get Rust and Go. These are both compiled languages. Okay, so first we'll get Rust on the board. And they offer different sort of benefits. Rust, I would say, is a little bit harder language to learn. Oops, Control Z, I want the actual image. Okay. It's a little bit harder language to learn, but I think it does have like a tiny speed benefit over Golang. Golang, I think, is a little bit easier to learn, a little bit more developer friendly. Still, if you were learning, like if you just learned PHP, any of these, PHP, Python, Ruby, JavaScript, you'd find Rust and Go probably a little bit more difficult in general. So Rust does have some nice speed benefits, like Deno, the new JavaScript runtime. That is actually created in Rust. I think the original Node was created in C++. Okay, just to give you some context. Go, a lot of companies are changing their backends that they previously had created in Ruby or Python and moving over to Go. Because Go, okay, let me get the Go logo. It's fine, a fun one. Because I like the Go mascot, so I want to make sure the Go mascot's in there. This one works for me. Okay. Now, Go, which is a language that was created by Google, is, again, also a compiled language. I think it's I found it easier to learn than Rust and C++. But it's also that lower level API for speed. So a lot of people are like transferring their applications that were using sort of interpreted lower speed languages and moving them over to Go. So that's a big thing, and you're starting to see a lot more demand for Go. So Go is a good space to be in. So is Rust. Okay, these are good places to be in because people are using these because they do provide that more modern syntax and modern package management and stuff like that. But you're getting like the similar speed benefits of using something like C++. Okay, then there's the whole .NET framework. I'm just going to put that as one big lump in those three languages. Let me see if I can find an image that includes the names of the languages. C# and F#. Okay. No. Okay, so let's just take the .NET framework and get that. Now, the .NET framework is essentially Microsoft's big thing. Like, basically, if you're programming within the Microsoft ecosystem and everything kind of works together, you have this .NET framework. And the .NET framework is kind of unique in the sense that it's one framework of APIs that work for building Windows applications for Windows platforms. And you can also build mobile apps, but it doesn't lock you into one particular language. If you're programming in .NET, you could do parts of your application in either C#, F#, or VB.NET, which is the successor to Visual Basic. Now, you could do that, and the cool thing about that is that the code will work together because they all borrow from sort of the same sort of shared libraries, and it all gets compiled in the .NET framework depending on what you're doing. There's like Xamarin for building like mobile apps in .NET. There's Blazor for building like website front ends now because it actually compiles. Well, technically it's like a runtime that interprets .NET code that runs in the browser to allow you to kind of create a website front end through WebAssembly, which is pretty cool. Basically what they did is they created the runtime in WebAssembly, so what's running in the browser is the runtime, and then you're seeing the result of your interpreted .NET code. Overall, still a very cool project. So that's Blazor, Xamarin for mobile applications. There's the .NET, ASP.NET framework, which is all about making web applications. So there's plenty of stuff. The .NET thing is its own universe. But just as like a little side note, C# goes beyond .NET. It's also become very popular in gaming with gaming engines like Unity. I would say it's really sort of become the language of game development. Like you'll find libraries for making games in all these languages. Like if you can type in JavaScript gaming library, Python gaming library, but when you're using things like Unity, Godot, and the Unreal Engine for building games, you'll oftentimes see that C# is the language of choice. So there's that. Okay, there's a couple also little languages you probably may have not have heard of, such as Ballerina. Okay, see if I can find the logo for Ballerina Lang. There we go. Now, I like Ballerina quite a bit. I do wish to see this language become more popular. It's really cool. What it is a compiled, so I'm going to put that in the compiled category. And this is a language created for, particularly for the web nowadays. So it's compiled. You find libraries for most of the things you'd find in any language, but it actually has libraries for, containerization of the application and deployment of the application. Okay, built into the standard library set, built into the language. So basically, the language can generate like Docker containers and do all sorts of cool stuff regarding automating the infrastructure, cloud infrastructure for a particular web application, which is really, really cool. And I like the syntax, like some of the ideas that it has and incorporates. It's actually, to be more precise, technically Ballerina is a virtual machine language. Technically, it runs in the Java virtual machine. Okay, now that I think about it. So that should go over here. Okay, and there's a whole host of languages that run in the Java virtual machine. Okay, and not all of them I have particularly a lot of experience with, but there's like things like Scala. Okay, Scala is I think it's object oriented. Again, this particular language I have less experience with, but it is in the Java virtual machine. I think I did do like a 30-minute video where I played with Scala for like 30 minutes, so you can see like the basic syntax. I think I've done at least one video on most of these languages. Many of them I've done full-on tutorial sets. But there's Scala. Then also there is Scheme. Also, I think has a. I mean, Scheme is an older language, older than the Java virtual machine. And again, if you're not familiar with what the Java virtual machine is, Java's big thing when it came out, as a language, was that you don't have to compile the code to Windows bytecode or compile it to Mac OS bytecode, because all the code just runs in this virtual machine. Basically, you compile it to Java bytecode, which runs in the virtual machine. So that technically, as long as the virtual machine is on a Mac or Windows computer, you could run the code. So that's the whole idea of write once, run anywhere. Because back in the day, you'd have to like make multiple versions of your software depending on the operating system. In the same way, you'd make multiple versions of your software depending on like what mobile operating system you're targeting. Although there's becoming more and more sort of cross-platform type solutions. Okay, and the Java virtual machine was one of them. But then people created other languages other than just Java, or implementations of existing languages, because so there are implementations of Python and Ruby that work in the Java virtual machine. These are like Scheme language logo, so I guess that is the logo. Copy. Okay, but basically those languages, what they would do is that they would create a version of the language that compiles to Java bytecode. Which the cool thing about that is that means you can use Java libraries. Okay, so you can use Java libraries, and you could run the code anywhere because it would just run anywhere the virtual machine runs. Okay, probably the most famous of these languages, that's beyond Java. So let me get Java on there first. Okay. Okay. I just want the logo. Okay, there we go. So let's get Java on the board. Okay. And again, just to reacquaint everybody, Java. Again, and when I hear I'm talking about the virtual machine, I'm particularly talking about the Java virtual machine. There is a couple other virtual machines like the Vadim virtual machine and the Erlang virtual machine. And technically, I did mention the Hip Hop virtual machine that Facebook made earlier. So there's other implementations of this idea of a virtual machine that you get your code writes for. So in that case, it's platform agnostic because you just run the virtual machine and the software runs in the virtual machine. But this is Java, of course, runs in the Java virtual machine. We have Scala, Scheme, Ballerina, but most famous nowadays is Kotlin. Kotlin's sort of become the successor for Java in many situations. It's a much more modern syntax, easier language to write in. So basically, this is starting to become sort of the norm if you're working in the Java virtual machine, and it interops with all the Java libraries. So you can use Spring and all those other really popular Java libraries with Kotlin and make Android applications. So that's becoming a cool thing. Okay, so that's Kotlin. And on that, since I mentioned Kotlin, we just bring in Swift. Okay, Swift has become the successor of Objective-C. Objective-C was a compiled language. That one I'm not going to bother listing on the list. It's still used for like a lot of Mac applications because that was sort of like the Mac language. I'm pretty sure that was a compiled language, lower level, so again, a lot more typing. But nowadays, everyone's moving over to Swift. Swift has sort of become the new language for the Mac space to replace Objective-C, particularly for making mobile iOS applications. Okay, now Swift, I want to say it's interpreted. I'm pretty sure like I don't have to, when I've ran Swift code, like when I run Swift scripts on there, I can just run them as scripts. Although you can compile them to like, mobile code using things like Xcode. So it's kind of in a weird in-between space. Kotlin definitely runs in the virtual machine, then it can be compiled to native Android OS code. Okay, we'll put Swift there. And again, that's generally the language for Apple iPhones, but again, it's a general purpose language. You can do other things. You can write web servers in Swift. Same thing with Kotlin. Generally, you can write a web server in any language. Okay, so backend work can be done in any language, which means it's impossible to learn everything when it comes to the backend, as far as doing the same thing in every language. Okay, cool. Let's see here. So we got the interpreted languages, compiled languages, anything I want to add there. Transpiled languages, let's add a few there. Okay, I want to mention reason script. Technically, there was a language called OCaml, which I'll bring back up again on the next slide. But OCaml is a functional programming language. It's still used. People like it. There's a whole sort of subculture of people who really like functional programming, and they like building their applications there. From what I understand, like if you actually like truly appreciate like and learn functional programming, you can end up writing a lot less code and a lot less buggy code. But it is tricky. Like I've taken some stabs at it, and it's not necessarily something that you can easily adjust to. Okay, and then there's Reason's logo, which reminds me a lot of Reason Magazine's logo, ironically, is a language that was created based on OCaml. So it basically took the syntax from OCaml and the syntax of JavaScript and kind of created this in-between language. It basically was created to do what TypeScript is doing, in the sense of giving sort of like a more typed, safe language for transpiling to JavaScript. So it still exists. They just rebranded to Reason Script, and I think they ditched the OCaml, because before you could do Reason or OCaml and transpile it to JavaScript. But they ditched the OCaml bindings and are just focusing on the Reason bindings with JavaScript. It's pretty cool. There's some interesting ideas in there. There's some aspects of the syntax that I like. There's some videos I've done on the Reason language. But that is a transpiled language. Another famous, and a lot of these transpiled languages are going to be transpiled to JavaScript, by the way. There's CoffeeScript. Okay. I kind of came around after I got involved basically after CoffeeScript sort of time in the sun. But there was a time where basically, again, Rails was really popular. So Rails dominated backend. Everyone was learning Ruby to do backend work. Then Node came into the picture and allowed you to do JavaScript in the backend. And to entice a lot of Ruby developers, this kind of middle language kind of popped up in there that has like a lot of Ruby-esque syntax, but a lot of JavaScript-y types ideas as well that transpiles into JavaScript. This was like a very popular way of doing your applications before like ES6. I think ES6 introduced that's JavaScript, ECMAScript version 6. There was a lot of syntax that got brought in with ES6 that just made sort of the marginal benefit of just using JavaScript directly less. So CoffeeScript has become less popular. It's still around. There's still a lot of projects that use CoffeeScript, and I'm pretty sure it's still being maintained. But that is a transpiled language. Okay, so I think those are sort of like the main category of languages. Let me just think if there's anything I'm particularly missing. No, there are some more languages I'd like to list. I'm going to copy one of these boxes onto the next page. Copy. Let's duplicate this. Okay, and what I want is a list of functional languages. These are languages that follow sort of a more functional paradigm. I'm not going to get into whether they're transpiled, compiled here, because for a lot of them, I just don't know. Okay, but all these languages, I'm not mentioning like languages that I know that are like outright dead, okay, or aren't really going to be used again anytime soon. So I'm trying to, but I'm trying to make this an exhaustive list of languages, so that way you know, okay, and you have an idea of what's out there. I find it interesting. I love learning new languages and kind of seeing the different syntactical ideas between them. They help me think about code in different ways, and understand the way the data is being manipulated more, which has definitely made me, I feel, a better programmer. But let's start off with functional languages. Okay, so like the old school ones, of course, like the OG functional language is Lisp. Okay. Have you ever done anything in a Lisp or Lisp-like language? You know there's a lot of parentheses. Okay, so that's Lisp. Lots of parentheses. Too many parentheses. Not my favorite thing in the whole world. Now, based on Lisp, there's a language that's it's kind of like the successor to Lisp, and also they have a version of it called ClojureScript for web, but Clojure. Okay, Clojure is a growingly popular functional language. Okay, basically takes a lot of the ideas of Lisp and just tries to make a more practical application with package managers, all the bells and whistles of a modern language. Okay, so there's that. Okay, then there's Erlang, which I think has its own virtual machine, and there's other languages that compile to the Erlang virtual machine. That I'm a little bit less of an expert on, but it's another popular sort of language. You can do anything you want there. You can build mobile backends, all sorts of applications. But it's another language with a functional approach. I'm pretty sure Elixir, which is another language, is a functional language. Elixir is a language that takes from Erlang in the sense that its syntax is borrowed from Erlang syntax. But again, it's a much more web-specific type language, built specifically for web backend. It's popular among, again, a lot of these functional languages, they're built because they're generally very type safe, they're very secure, and they're fast. So you can build so people who really understand sort of that functional approach, and understand the Erlang or Lisp or Haskell syntax, they can build pretty low maintenance code in the sense you don't have to go back and fix it or adjust it much. It just kind of works. At least that's sort of the vibe I get when I hear people talk about it. Again, haven't built anything in these particular languages. I've dabbled to really kind of truly appreciate the differences. But there's a lot of good lectures on YouTube from different conferences that are worth listening to. But also, let me just bring up Elm since I mentioned like web-specific languages. And Elm is unique that it's a functional front-end language. And actually this I will bring back up to the previous page because this is another transpiled language. But this is transpiled specifically for front-end code. Okay, so in lieu of using like React, Angular, or something like this, you would write your code through sort of an imperative functional syntax. So it has like a React-y feel in a sense where there's like state, and it's imperative in the sense like if you ever use React, you're saying, okay, this is how things look, and it updates as the data changes, but you're really kind of painting like the picture of a moment instead of painting a list. Basically, you're describing an image more than you're necessarily putting an ordered list of instructions. And then as the data changes, the picture gets repainted, in a sense. And that's kind of what Elm is for. So it's a language specifically for one thing, to give you a very succinct way to write your sort of your front end, and then it gets compiled to HTML, CSS, and JavaScript. So it's an interesting one. Um, One I haven't really dabbled with too much, but I've heard a lot of good things about. Then there's Haskell. Okay, if you ever want to torture yourself, uh, learn Haskell. Um, it's a people who learned it and are good with it love it. But the errors are a little tricky. The syntax is a little terse, a little hard to kind of wrap your head around at first. But people who like it love it. And F sharp is based on Haskell's syntax. And then there's one other language that's escaping me at the moment that's based on, I guess F sharp is the main one. But I thought there was another language here: Elixir, Clojure, Elm. There's one that I'm missing, and it's not coming to me now. Let's do a quick Google search: language based on Haskell. Okay. If I say it real quick, so see here: dialects influenced by, influenced. Yep. No, not Scala. Oh, I gotta go back and mention Perl. Java, sure. We just covered all those. Okay. I'm not finding it at the moment. I thought there was, but F sharp is based on Haskell. That's for sure. Okay, Clojure is kind of based on Lisp, and Elixir is kind of based on Erlang. But what I do want to go back and add Perl and Raku. Okay, which are also generally, again, mostly web-specific languages for building like web backends, but worth listing because it's starting to make a comeback. Okay, so here's a more modern logo for Perl 5. Perl 5 is trying to rebrand itself, and I think they're working on making Perl 7. And you're probably thinking, wait a second, why are they going from Perl 5 to Perl 7? Well, the reason is that they did come out with a Perl 6. Perl 6 was just so different that it ended up being pretty much a different language. So all the people who used to do Perl beforehand were kind of upset, being like, hey, this is too different. You're making us learn a whole new language. We want to kind of keep things the way they've been and just approve upon it instead of just redoing the whole thing. So Perl 6 broke off and became Raku. And now it's its own language, being separately maintained. And then Perl 5 is going to continue on as Perl 7. Okay, and then Raku has, again, they have a robust... Perl is a pretty old language in the web. It's a pretty verbose language in the sense it has a lot of syntax. Some of it's kind of cool in the sense that, like, Perl probably has a interesting syntactical shortcut to do anything you can probably think of. Problem is there's so many of these like syntactical shortcuts and syntactical things that it's tough to keep it all straight, and you kind of have to learn a lot of them so you can read other people's code because there are people who've learned all these things. So it is a tricky language to learn. I can definitely see the benefits of it. Like, there's a lot of aspects of the syntax that I can see. Like, once you kind of get good with it, you could be pretty productive, and it can actually be a pretty fun language to develop in. And Raku just takes that to sort of another level. Streamlines some things, but it also changes the terms for like a lot of just the basic core functions. So it just was different enough that it just required it to just kind of go down its own path. I think at this point we've covered the world of different languages pretty well. So hopefully this gave you a pretty good idea of all the different languages out there. There are still more I didn't mention. Like I didn't go into Objective-C. I didn't go into R, which is a language that's highly used for like statistical analysis. That's also kind of Lispy with the parentheses. But I think this gives you a pretty good solid foundation on the options that are out there and sort of where they fit into the world, and hopefully, encourage you to go dabble, learn all of them. Find one language as sort of like the language you kind of really build your fundamental understanding of programming concepts in. But once you have that solid foundation in programming concepts, you can go back and learn any of these fairly quickly. Nowadays, if someone tosses me a new language, once I get like the compiler or interpreter set up, you give me a couple hours, I can write functions, write objects, do all the basic stuff. So, yeah, have a great day. My name is Alex Merced, and we were talking about programming languages in 2020. Ciao.